Welcome. My name is Raina Eckhart Fitzgerald. I'm a doctoral student at Plymouth State University and the Mathematics Program Coordinator at Manchester Community College in New Hampshire. In this presentation, I will be sharing my results from a recent action research study that I completed on the influence of digital communication technologies on students' effect and academic achievement when learning mathematics. Mirroring lessons to the cloud. The specific question of inquiry in this action research is, what is the impact on secondary mathematics students' emotions, attitudes, beliefs, and learning when the presentation of their class lessons, discussion notes, and homework assignments are simultaneously mirrored to the internet for students to access later? The participants in this study were 12th grade AP Calculus and 10th grade Honors Geometry students at Bishop Brady High School in Concord, New Hampshire. Bishop Brady is a private Catholic co-educational regional high school. These students range in age from 15 to 19 years old, and although these students are primarily from the southern New Hampshire region, there is a diversity in their population through the international program, which brings in students from China, Korea, Thailand, Vietnam, Germany, and Spain. During this mixed method technology intervention action research study, both qualitative and quantitative data were collected. The technology intervention implemented allowed students in the experimental group to review class lessons and notes from the internet. Information written during class discussions and homework review and students' written contributions were shared in the classroom with the use of an iPad, air syncing to a MacBook Air, and then displaying on a screen, while simultaneously being saved to a Dropbox for students to access later. Each time a new lesson was presented, it was simultaneously recorded and then also saved, but this time as a YouTube video for students to rewatch later. The time frame for this action research was approximately 4 months, running from September to December of 2014. The qualitative data collected during this action research included classroom observations, anonymous surveys, open-ended anonymous questionnaires, and open-ended interviews. Through the use of classroom observations during the intervention, it became evident that students who previously struggled with note-taking appeared to follow course lectures better and to participate more frequently. Students who were sometimes chatty were now quiet during the video recordings of new lessons. During these lesson recordings, students quietly followed along well with little distraction. As students became more comfortable with the recording of lessons, they began asking constructive questions during the recordings. Overall, the classroom observations indicate that the students were enthusiastic about the use of technology in the classroom. Student athletes who had struggled in their math courses during the previous year were pleased that they would no longer miss class lessons when they left for school competitions. Instead, these students would watch the online lesson videos, look through the online notes, complete their homework assignments, and return to class well prepared. The Likert Scale survey questions revealed that students agreed that the course resources contributed to their understanding of the subject. Students also agreed that the use of technology was helpful. One student did disagree that the student's learning management system was helpful. The qualitative analysis of the open-ended questions in the anonymous student surveys revealed that the majority of students were pleased with the use of technology in the classroom. When describing their thoughts on the use of this, they use words like helps, accessible, helpful, benefit, clarify, and confident. These students described different ways in which the technology benefited their learning. One student wrote that the use of the iPad with a projector, quote, helps to clarify concepts. Several students explained that the use of technology helped them, quote, to feel confident going into tests. Only one student wrote a negative comment about the use of technology with the following statement: "I wish sometimes she would just use the board when going over homework." When evaluating students' perspectives on the class lessons and homework review notes that were made available on the internet, it became evident that students were pleased with this technology. They wrote positive comments about the online course notes. They used these words to describe them: like, love, accessible, available, helpful, helps, understand, refresher, look up, and examples. One student explained that it helped to make everyone's life easier because all of the notes in class are available online. This student suggested that more instructors should use this technology. Several students explained that the online class notes were helpful when they were absent from class due to sports or illness. Although many students described the notes as organized, one student expressed, quote, "Sometimes the order and labeling of the notes is confusing." Other students explained that the online course notes helped them to understand the material more easily, especially at night when they were able to look up the examples online. A qualitative analysis of the student's perspective of the online lesson videos also revealed that students were pleased with this technology. Students wrote that they appreciate the lesson videos that were available to them online. They used these words to describe the lesson videos: like, love, handy, accessible, and helpful. The students explained that they did not fall behind on learning material when they missed class lessons because they would watch the lesson videos at home. They also described situations in which they would refresh their memory of class lessons by watching the lesson videos at night. One student explained that when watching the lesson videos, he found things that he had missed during class. Several students explained that the ability to pause and rewind the lesson videos helped them to better understand the lesson. They also found that the videos were helpful during their test preparation time. One student wrote, quote, "I am someone who understands in class, but sometimes gets lost in the homework. So, I like being able to look back at the videos." Only one student explained that she did not use the videos because she did fine without them. The student interviews revealed that while many students liked both the online class notes and the lesson videos, many students viewed the online class notes much more frequently than the lesson videos. These students' interviews revealed that the videos appeared to increase in value to students when the students needed them as a scaffolding device for learning. The quantitative data consists of 3 summative assessments given to both the geometry and the calculus groups. The 3 summative assessments given to the geometry groups were given to both the control and the experimental geometry groups after the intervention began with the experimental geometry group. The first summative assessment for the calculus groups were given to both the control and the experimental groups prior to the commencement of the intervention. After the intervention began with the calculus experimental group, the final 2 summative assessments were given to both the calculus control and calculus experimental groups. These box plots represent calculus students' scores for the 3 assessments. Here, we paired the students based on their SAT scores. So for any student in the control group, we would match that student with a student from the intervention group based on having either the same SAT score or a score that was very close. This reduced our sample size down, but gave us a better picture of performance, because now we're comparing the same type of students. In this first 2 box plots, we have our pre-assessment, which is prior to the intervention. On the left, we have our control group, and on the right, we have our intervention group prior to the commencement of the intervention. Here we can see that our control group students are actually performing better than our intervention students. Now, this may mean that our control group students are better prepared and have a more solid foundation in pre-calculus. Now we move on to our second two box plots, which represent our second assessment. Now these are after the intervention has begun. And here we can see that the scores for our control group versus the the intervention group are no longer higher than the intervention group. The intervention group scores have now become stronger than the control group, whereas before you could see before the assessment our control group was higher. Now as we move on to our third set of two box plots, which is after the third assessment, now we see that our control group is still significantly lower than our intervention group. So this indicates that the students in the intervention group are performing better than the students in the control group. So it does seem that the technology is influencing and helping with the learning. And this is where we get to derivatives. The students are learning derivatives. So here we've got our control group. It's sort of struggling a bit, but our intervention group is sort of maintaining a high level. And that is, we're assuming, because of the technology. Here we have box plots that give us a picture of the results from the geometry assessment scores. These assessment scores were set up with pair matching based on PSAT scores. So each student in the control group was matched with a student from the intervention group based on having the same or very close to the same PSAT score. In our first assessment test, we see the two box plots that represent the results for the control group and the intervention group. We can see that the control group scores overall are lower than the intervention group scores. As we move on to the second assessment, the results from the second assessment, from these two box plots in the middle, we see again that the control group scores continue to be lower than the intervention group scores. And finally, in our last assessment, this is where the work becomes rigorous. The students start solving or proving rigorous proofs. And it is traditionally for this course, this third assessment is where we have students that do not do well. They really struggle. And you can see from this first quartile here, the bottom quartile, that we have some struggling students. And these students frequently move to a college prep geometry course from this more advanced, rigorous honors geometry course. This did not happen in our intervention group. All of our students are passing and doing well here, as you can see, for the students that are in the intervention group. And as you see, our three box plots that represent our intervention group from assessment 1 to assessment 2 to assessment 3 maintain fairly high overall assessment scores. And if we look at the control group, we see in our three control group assessment score box plots, the scores are actually decreasing overall as the work gets more challenging. So it seems that, in fact, the technology is helping in the intervention group. Now, for these three assessments, these scores were compared based on their mean scores using a student t-test, and we found that with a 95% confidence level, the intervention group scores were statistically significant in being having higher means than our control group scores. As 21st century educators, it is our responsibility to integrate technology appropriately into our teaching to effectively educate our students. This research demonstrates the benefits of mirroring mathematics lessons to the Internet. While more research should be done in this area, the technology for this exists now, and educators should consider integrating this technology into their teaching. Thank you for watching this Action Research presentation on mirroring lessons to the cloud.